Pluto's orbit around the Sun is strange and unique. Unlike the nearly circular paths followed by the major planets, Pluto's orbit is both stretched out and tilted compared to the rest. One of the most surprising facts? Pluto's orbit actually crosses inside Neptune's. At certain times, Pluto is even closer to the Sun than Neptune is. You might think that means a collision is inevitable, but thanks to the invisible forces of gravity, the two never crash into each other. The secret lies in a complex cosmic dance governed by what scientists call the three-body problem. In this case, it's Pluto, Neptune, and the Sun, constantly pulling on each other and adjusting their paths. While the three-body problem is famously chaotic, Pluto's orbit is stabilized by several special gravitational tricks. One important effect is known as alpha vibration. Whenever Pluto's orbit crosses Neptune's, Pluto is always about 90 degrees ahead or behind Neptune. They are never in the same spot at the same time. Another stabilizing factor is extension vibration, which keeps Pluto above or below Neptune's orbital plane during close approaches. A third effect, called the VZK sway, further locks Pluto's orbit into a safe, repeating pattern. Together, these gravitational mechanisms protect Pluto from any dangerous encounters. By the late 1980s, scientists ran computer simulations that confirmed Pluto's stability isn't temporary. It should last for millions, even billions of years. The giant planets, especially Jupiter, act like cosmic bodyguards, gently tugging Pluto back onto a safe path whenever it drifts too far. These gravitational forces have kept Pluto in check ever since the early days of the solar system. The story of Pluto and Neptune is also a story of orbital resonance. Pluto completes 2 trips around the Sun for every 3 Neptune makes. This 3-to-2 rhythm keeps their movements locked together. Even though their orbits overlap, the timing is perfect, they never come close enough to collide. Pluto isn't alone in this resonance. A whole population of small icy worlds called Plutinos also share the same 3-to-2 pattern with Neptune. This shows that Neptune's gravity doesn't just influence one object, it shaped an entire region of the outer solar system. Pluto's odd orbit also tells the story of planetary migration. Long ago, Neptune slowly drifted outward, disturbing the orbits of countless smaller objects. These movements likely nudged Pluto into its tilted, elongated path. Migration reshaped the solar system, creating structures like the Kuiper Belt, the vast ring of icy debris where Pluto resides. Every so often, Pluto's orbit is lightly disturbed by encounters with other Kuiper Belt objects. These tiny gravitational nudges add up over millions of years but rarely cause dramatic changes. Overall, Pluto's orbit remains remarkably stable thanks to the protections built into its relationship with Neptune and the other giant planets. Despite its small size and remote location, Pluto reveals a lot about how the solar system works. It teaches us that even in the distant, icy outer regions, gravity weaves a hidden order through seeming chaos. When the New Horizons spacecraft flew past Pluto in 2015, it revealed a world unlike anything we had imagined. Towering mountains of water ice, smooth plains of frozen nitrogen, and mysterious glaciers marked the surface. The most famous feature, Sputnik Planitia, is a vast heart-shaped plain that may still be geologically active today. Pluto also has a thin but fascinating atmosphere made mostly of nitrogen, with traces of methane and carbon monoxide. This atmosphere expands and collapses dramatically as Pluto moves closer to or farther from the Sun, causing cycles of freezing and thawing that reshape the surface over time. Adding to Pluto's uniqueness is its largest moon, Charon. Almost half Pluto's size, Charon and Pluto are gravitationally locked together, orbiting a shared point that lies between them. This rare setup makes Pluto and Charon more of a double planet system than a typical planet and moon. Their gravitational partnership also affects smaller moons and possibly shapes the space around them. By studying Pluto and its place in the Kuiper Belt, scientists gain clues about how planetary systems form and evolve. Far from being a lonely outcast, Pluto is a key to understanding the frozen frontier of our solar neighborhood. In 2006, Pluto was reclassified from a planet to a dwarf planet, a decision that remains controversial even today. But Pluto's importance didn't shrink with its title. If anything, the mysteries of its orbit and its stunning landscapes only deepened our fascination. Pluto's enduring journey, safeguarded by delicate gravitational harmonies, reminds us that space, while vast and often chaotic, also operates with surprising precision. Even in the far reaches beyond Neptune, patterns emerge, stability forms, and beauty endures. The story of Pluto isn't just about one icy world. It's a window into how the forces of gravity, motion, and time shape everything we see, and much we have yet to discover. Thanks for joining us on this journey to the outer reaches of the solar system. For more amazing explorations, be sure to subscribe to Discovery at 2.0. See you in the next adventure.